Okay, so Assalamualaikum warahmatullahi wabarakatuh. Good day, everyone. We are group 5 from class MBA 46, the FMS 02. So, in this presentation, we will explain our answers to the investment business process that have been given before. But before we begin, let me introduce myself and my team. My name is Muhammad Feris Mayana, and I'm here with my team, Fatia Anura, Winky Komunita Nixon, Nabisa Mutiara Indonesia, and Hibatura Halakausa. Okay, so without further ado, let's move on to the first case, which will be explained by Fatia Amir.
So in the first case, we have to redo the analysis using NPV to determine which project should the firm choose. The prior analysis has ranked the proposals according to their IRR and recommended the highest IRR option, which was proposal A. We have to evaluate whether the recommendation was appropriate. We were provided with information of cost of capital that equals to 10% and a table containing IRR and cash flow information for each proposal, but the cash flow information for some proposals still missing. Next. Okay, so to calculate the initial, to calculate the data that's still missing on the table, in the first one, we have to calculate initial investment of proposal B using the NPV formula and using the IRR of proposal B that equals to 55%. The IRR is a discount rate that makes the net present value of all cash flow equals to 0. So after the calculation, we found that initial investment of proposal B is 111.37. And to calculate the additional salvage value at year 3 in proposal C, we also using the NPV formula. And from the calculation, we know that additional salvage value in year 3 is 50.24. Next. And after calculate the additional salvage value, we know that the cash flow in year 3 of proposal C is 254.24. So we can complete the data and the table, and we can calculate the NPV of each proposal. For proposal A, the NPV is $119.82. For proposal B, the NPV is 130.36. Next. And last one, for the proposal C, the NPV is 124.65. And for the conclusion, based on the net present value analysis, the firm should choose project B as it offers the highest NPV among the 3 options. According to the NPV rule, a firm should always choose the project that provides the greatest positive NPV as it maximizes shareholder value and indicates the highest return over the cost of capital. Although projects A and C also yield positive in NPVs and are financially viable, project B stands out as the most profitable investment. For additional notes, investment decision should not rely solely on IRR, but rather on how much net value the project can generate for the company. And ranking the project by their RRR is not valid in these situations because the projects have different scales and different patterns of cash flow over time.
Okay, so now let's move on to the second case, which I will read to you. You are deciding between two mutually exclusive investment opportunities. What encourages an initial investment of $10 million? Investment A will generate $2 million per year, starting at the end of the first year in perpetuity. Investment B will generate $1.5 million at the end of the first year, and its revenues will grow at 2% per year for every year after that. So the questions for the second case are: question A, which investment has the higher IRR? Question B, which investment has the higher NPV when the cost of capital is 7%? And question number C, in this case, for what values of the cost of capital does picking the higher IRR? Give the correct answer as to which investment is the best option. Now I will answer the question which investment has the highest internal rate of return of IRR. So we are comparing two investment actions, A and B, both of which require an initial capital investment of $10 million. Investment A is straightforward. It generates a consistent return of $2 million annually. On the other hand, investment B starts with a return of $1.5 million in the first year, but this amount increases by 2% each subsequent year, affecting a growth return over time. To determine which investment are better, we calculate the IRR by setting the net present value of each investment to zero and solving for the discount rate, denoted by R. For investment A, the cash flows are consistent, so the NPV is calculated using the formula NPV equals min 10 plus 2R. Setting NPV to 0 and solving for R, we get 0 equals 10 plus 2R equals 10 equals 2R equals R equals 0.3 of 20%. This means investment A has an IRR of 20%. Investment B's returns are variable due to the 2% cost each year. So we use a geometric progression in the NPV formula. The NPV becomes NPVB equals min 10 plus 1.5 R minus 0.02. Solving for R, we get 0 equals min 10 plus 1.5 over R min 0.02 equals 10 equals 1.5 over R minus 0.02. So yeah, we get R equals 0.17% and 17 or 17%. So investment B has an IRR of 17%. So the conclusion down here is that although investment B offers a growing return over time, investment A still outperforms in terms of IRR. Therefore, investment A is a better choice when evaluating based on IRR, with a return of 20% compared to investment B's 17%. Next.
Okay, now we will get into point B for this case. So the question is, which investment has the higher NPV when the cost of capital is 7%? And we get the information given here, and basically the information is the same with point A. So we will get into the calculation, and we will start from investment A, and we will using NPV for the calculation. So the NPV A equals to divide 0.07 minus 10 equals 28.57, and 28.57 minus 10 equals 18.57, and the NPVB equals 1.5 divide 0.07 minus 0.02 minus 10. It equals to 30, and the 30 minus 10 equals 20.0. And the conclusion is investment B is more profitable than investment A at 7% discount rate because it generates a higher NPV of 20.0. This shows that although the initial cash flow of investment B are smaller than investment A, the 2% annual growth in its cash flow has a significant impact on the total value of the project in the long run. In the other words, the growth nature of investment B's cash flow makes it more economically valuable than the fixed cash flow of investment A, when the cost of capital is moderate level of 7%.
Okay, so the third case and the second case is for which values of the cost of capital is to the higher consumer recommendation with the correct decision. So, in other words, we are trying to understand when the IRR method aligns with the NPV approach in determining the better investment. To find the answer, we analyze a graph that shows how the NPV of both investments changes with different discount rates. As seen in the chart, there is a specific point where the NPV lines of both projects intersect. This intersection represents the discount rate at which both investments yield the same NPV. So we set the NPV of both investments equal to over R equals 1.5 equal per R minus 0.02. So we solve the equation by 1.5 R equals to R min 0.04 equals 0.5 R equals 0.04. So we get the R is 0.08. So the NPV of both investments is equal when the discount rate is 8%. So the conclusion is for cost of capital greater than 8%, the IRR rule gives the correct answer. In this case, investment A is the better opportunity whenever the cost of capital exceeds 8% and vice versa. Next. So the third question is, the third case is you have three projects with the following cash flow. So this case have three questions. A, for which of these projects is the IRR reliable? Question B, estimate the IRR for each project. So then that's 1%. The question C is what is the NPV of each project if the cost of capital is 5%, 20%, and 50%. Next.
Okay, in this slide, I will discuss the IRR or internal rate of return reliability of several projects based on their cash flow pattern. Project 1 has one sign change from negative to positive. This is the conventional pattern where we invest initially negative and then reserve return positive in later years. In case like this, the IRR is usually reliable. Project 2 show two sign change from negative to positive, then back to negative. This is an unconventional pattern which might cause more than one IRR to appear, making the IRR unreliable. Project 3 is only one sign change, but from positive to negative. This is also an unconventional pattern because usually investments start from negative number. Since the initial investment is actually positive, the IRR of this project can also be misleading or less reliable. In conclusion, IRR is most reliable if the case flow have only one sign change from negative to positive as in project 1. Next. Okay, in this slide, we calculate the IRR for three projects with different cash flow. Project 1, the cash flow changed from negative to positive just once, so the IRR can be calculated accurately at 10.2%. Project 2, the cash flow changed from negative to positive and then back to negative, resulting in an IRR of 49.5%, but since the sign changed more than once, the IRR is not unique. Next. Project 3, the cash flow start positive and then negative at the end, also resulting in an IRR of 11.2%, which cannot be used as a decision basis because it's not unique. In conclusion, IRR is only reliable if the cash flow change sign once for project with unconventional cash flow pattern. NPV is more recommended as the results are more stable and accurate. Next.
Okay, we move to NPV of each project if the cost of capital 5%, 20%, and 50%. After we calculate the NPV, it's found that if the cost of capital is 5%, project 1 can have a change because they have a positive NPV result. But if the risk is high, which 20% or 50% discount, the NPV becomes negative, so it's not feasible. If the cost of capital is 20%, project 2 have positive NPV result and the highest NPV. this project is very sensitive to change in discounting and also high fluctuation or large differences between NPVs. The meaning is the risk is also high. Meanwhile, with cost of capital 50%, project 2 and 3 have a positive NPV, and the project 3 has get the highest NPV. Project 3 is profitable under high risk because the initial cost is small and the initial cash flow is large enough. Next. The conclusion is project 1 is best for low cost capital, which 5% but deteriorates as rates rise. Project 2 is feasible only at moderate rates, which 20%. Project 3 performs initially well under very high discount rates, which 50%, making it a potential hedge against high financing costs. However, if the company doesn't know how much capital, the more flexible project 3 can be taken because it's produced a positive NPV at cost of capital 20% and 50%. So it's safe for uncertain economic condition with a higher cost of capital or interest rate, but still feasible to run with unstable economic conditions. Next. So the final decision of case 3 is the optimal project depends on the firm cost of capital. Project 1 at 5%, project 2 is at 20%, and project 3 at 50%. A true risk assessment is recommended, especially for project 2 and 3, given their non-conventional cash flow.
Okay, so the recommendation from my friends concludes our presentation on our answers to the investment decision. We hope our explanation has been clear and insightful. And thank you for your attention and time. If there are any questions, we'll be happy to answer them. Once again, thank you so much and have a great day. Thank you.